So, hello everyone. The mysterious voice who's talking right now, this is Laura Doyle, and I am at the College of New Jersey's Center for Excellence in STEM Education. And the center currently has a 3-year fully funded project called Building CS in New Jersey, Building CS Capacity in New Jersey. And the main goal of the project is to increase the number of teachers who are teaching both computer science courses, but also using computer science in their classrooms. And so all of the professional development that we are offering is at no cost to the attendees. And so this fall, we just started it in July of 2016. And so this fall, we're getting our feet wet and we're starting with some webinars, and then we'll be doing, longer workshops that are in person, and summer workshops as well. And we'll be doing some things like, Arduino sessions with giveaways and whatnot. So this is kind of the beginning of the different PD that we're offering. So again, I'm the project manager here. If at any point you have any questions for me following up, you do have my email address, and I will be sending you guys a follow-up email as well. Just to let you know a little bit about the WebEx control panel that you're looking at. I know some of you are very familiar with unmuting, with muting your microphone and unmuting it. Bernard, hello again. I'm just going to unmute your mic real briefly. And then if you'd just like to tell us how many sections of AP CSP you're teaching and where, just so that everybody else can kind of know.
Hi, everybody. I'm not teaching AP. I teach in Trenton High School, and we are I'm trying to push to teach computer science in my school. I am a math teacher, actually.
Oh, okay.
And we're not there yet. I'm kind of doing like groundwork for the coming future, where hopefully we'll be able to teach computer science.
Okay, great. Thank you.
You're welcome.
Okay, so like I said, if at any point in time you do have a question and you want to use your microphone, just use the hand raising feature. You can unmute your microphone when you're done speaking, just in case you have a dog barking in the background or anything, embarrassing noises. If you'd rather type in your question, there's a feature to do that, and there's also a chat feature as well. So you can use any of those. And then throughout, we have a couple of different handouts that I don't know if we have to release these to you or if you're able to see them in your panel on the right-hand side, but there are 5 different handouts, and there will be 2 more that I can email you guys as well. So our presenter today is Barbara Froelich, and I'm going to let her tell you a little bit about herself. She has a lot of experience with teaching computer science, but specifically AP-CSP. So I will hand it off to her.
Hello, everyone. My name is Barbara Froelich. I have been teaching APCS principles. This will be my 4th year. My school was chosen as one of the pilot schools for to run APCS principles. I also teach all of the programming courses and all of the engineering courses. My background is I have a BS in biology. I started out as a biology teacher. I also have a BS in computer science from NJIT. So I'm an alternative school, an alternative route teacher. I worked in industry, but I also have a background in computer science. And I think that would be it. Oh, I'm also a AP Summer Institute consultant for College Board, as well as I was one of the initial readers for the first reading of the AP CS principles. And any questions? And we'll start. Oh. All right, so this webinar is to be talking about scaffolding activities towards the performance task and the pacing of the activities. And when a lot of people are setting up and doing the performance task. So the explore performance task is usually the first one everyone does, and that's usually done in the fall. And that leaves enough time for the students to do the create performance task, and that's well, in my class I usually have that done by March, because you have to have everything submitted by April 30th, and then once they submit it, and they submit it before April 30th, like they submit it the first week in April, and then we have the rest of the time to prep for the exam, which is May 5th this year in the afternoon. Okay. And I'm sure everybody knows that this course is based around the 7 principles, the 7 big ideas in computer science: data, algorithms, programming, the internet, impact, creativity, and abstraction. And they're all connected with computer science. We're going to be discussing, hold on for a moment. Sorry about that. We're going to be discussing the explore task and the create task. So as you can see here on this slide, the explore task talks about an innovation, and it connects creativity, data, and global impact, and the internet. And it's done individually. And you have the create performance task, which is programming, and it also connects the big ideas of creativity, abstraction, algorithm, and programming. It is collaborative, but a lot of the write-up, there's portions of it which have to be individual write-ups, and we're going to discuss that because, well, we'll discuss that when we get to the create performance task. You can see this screen here. So obviously there's 2 assessments. There's the performance tasks and the end of course exam. And the end of course exam is going to be 74 multiple choice questions. And my screens are jumping ahead. And the explore task discusses the impact of computing innovation. The create task is involved with programming. And we're going to be discussing the explore task first. So the explore task, as you can see here on this screen, it's focused on an innovation. It must be fairly recent. Some of the articles, at least 2 of the articles, can't be any more than a year old. I think they're saying now anything past the date of May 2016, the students can use, and it's 8 hours in class time, and the submissions are the computational artifact and written responses. And in the citations, they also have to have the insight citation as well as references. And here is the link to the rubric. You also have the new rubrics. I don't know. Has anyone seen the new rubrics for the explore task? I've given you a handout on that that came out just very recently, just this past November, and I think it's been posted in the AP community. So I'm sure everyone's familiar with it, but we can we're going to take a look at that as well. Okay, for scaffolding towards the Explore PT, and I'm going to discuss this. Well, we're going to see this slide, then I'm going to discuss each of these, so you can see that you have discussing binary and abstraction, computational thinking and algorithms, history of computing and innovations past and present, history of the internet, and then everything just jumped ahead. Cryptography, roles of data and impact of CS or global impact, and then in my classes we do mock explore performance tasks. So working towards the explore task, what I do is my students get 2 to 3 articles a week to analyze. So some of the articles I use for the ACM Tech News, Bits and Bytes, which I think they just are starting a new subscription because I got an email during CS Ed Week saying they're starting it up again. Whoops. And that's a really good. Those they have really good articles, and they kind of break down different innovations. In the past, they went and discussed, not that you could use that for the Explore test, but just to get the kids the idea of different innovations. In the past, they had in-depth articles on CAPTCHA and how it was developed and why it's used. And that's from CS Bits and Bytes. And then I also use Google Tech News. And sometimes just early in the morning, if I'm kind of surfing through my, on the TV, surfing through the channels, I just look at the tech news or, news from technology that, they're discussing, and then I kind of bring that into the class and we have a discussion that day. The one thing I did connect, and you'll probably see that later in my slides, is we did discussions on the 1600 Pennsylvania Ave app, which is augmented reality. And I'll show you in one of the slides. Basically, it takes a dollar bill, and the app converts it into the White House and tells you gives you information on the White House, which I showed it during CS Ed Week. And my AP students wrote about it as an innovation, and then they presented it to the middle school students as part of our computer science petting zoo, and the kids went crazy for it. And then abstraction, obviously we go through our learning binary. We have our binary flashcards. I connect abstraction with the representation of colors and numbers using hexadecimal. And then we convert from hexadecimal to binary to decimal, because that's there's a number of multiple choice questions where the students have to convert from hexadecimal to binary to decimal. We also just discussed the abstraction barrier. So I'm sure you guys are familiar with that. So you don't need to know all the components of a computer to work a computer. Also, you don't need to know all the components and how the brakes work, how hydraulics work, how the combustion engine works to drive a car. You just get in the car, put your seatbelt on, turn on the ignition, put the car in drive it. But there's a lot of information. There's a lot of abstractions beneath that. So we discussed that as a stepping off point, talking about abstraction. And then to connect that, that you don't need to know everything about the computer to use the computer, but there's a lot of components in the computer. We do a reverse engineering of a computer. And then the students have to give presentations on the function, and they talk about the different components. This is from my class. We use abstraction in every day. Basically, they went through and they gave examples of what they thought was abstractions in every day. So I have road signs. Somebody talked about emojis. This is someone's 2-slide presentation. Cell phones, how you don't need to know all the little components and all the programming behind the cell phone, but it's a very powerful small computer, and you just pick it up and you can take a picture, send a text message, make a phone call. But that's the abstraction barrier. There's a lot of programming and components behind that. And abstraction and science, we have this, and my presentation is jumping forward, I apologize. So we have the abstractions in science. So you can see men and women signing for the deaf, and also school signs. And gaming systems, the same thing. You don't need to know all the components in the gaming system to use it to play a game. And this one I liked, because basically, when you go to a restaurant, you're not sitting there and you're not saying, I want, ground beef made into a patty, cook the patty, put lettuce on it, put, pickles and put it on a bun. You say, I want a hamburger. in this example, basically there's more abstraction because you can order whatever you want by just saying, I want number 1 or I want number 2. So I liked this example. This is one of my students who used the examples of menu items. And also we use the algorithms, or the big idea of algorithms, to kind of build and scaffold towards their explore performance tasks. So we use pseudocode and flowcharting and board games and origami algorithms. Again, you saw, well, algorithms in everyday, basically, they're asked to write out in pseudocode how they would get to school, or how, what the steps are that they use to get up in the morning and, make sure they get to school on time. And also origami algorithm, and how precise you have to be with your algorithms and how you have to communicate that information properly, because you can get an algorithm, you can get an origami design that's really beautiful, but if you're not careful, the way you write down the steps, your partner is going to make something that doesn't look anything like what you've created. And this is just a few more examples for scaffolding for algorithmic board games. Everybody knows the PB&J algorithm. I use that for my freshman class, and a lot of times we use it as outreach to start programming with the middle school. And then I've had algorithmic board games, which is a lot of fun, and it kind of creates a nice classroom culture, because all the kids get to play their favorite childhood games, and then they have to write the algorithms for them. And here's another, I believe I gave you this worksheet. We use this sometimes in CS Ed Week, but I use this specific worksheet in a couple of different lessons. So I use it in the beginning of pseudocode, because you can take this and you can write, and you can change obviously the symbols here, but you can basically set the robot here, and then write an algorithm to have the robot or the piece of candy or the coin to move all over the grid. You could also use this for flowcharting as well. And I also go through history of computing. So I have some really good slides from Carnegie Mellon that you goes through a brief history of computing, and then we discuss the history of the internet, and also a discussion of cloud computing. All right, so these are just kind of a few activities I do in my class. I do quite a bit more, and I kind of connect them to the learning objectives and the essential knowledge. But what I'm building for is for the kids to have soft skills, or skills so they can go in and they could analyze their innovation and do their explore task. We also do mock explore tasks. As a whole group, we discuss innovations after they do some readings. I also have these forms that they could fill out, asking what their innovation is, what the function of the innovation is, list a few benefits and harms, how the data is, collecting the data input, how it's processed, the data output, and if there's any security concerns. So that way they kind of are used to analyzing different innovations. And also, to build upon that, they have the reading assignments from the Blown to Bits book. I'm sure everybody's familiar with that. And then just before they do the actual explore task, which our explore task is going to take place the first week in January, after the break. What they're doing right now is they're going to be doing mock explore tasks with writing prompts, and I sent a link with the writing prompts for you. I just basically took the directions and just kind of made a Word doc out of the writing prompts. So last year we did Google Exploration and IM Cardboard. We had some engineers come from Google to present the Google exploration to the whole entire school. So my students went around with the questions or modified questions that they would see in the explore task, and they went and they interviewed the engineers that came in. So they had a lot of good information. Then what I had them do is we created a Google Doc with those writing prompts, and they added in all of their answers. And we kind of analyzed that and decided which answers seemed to, or which write-ups whose write-up was the best in answering the question. And so we worked on that for a day or two. And then they also had videos and pictures, and I told them that they needed to create a non-textual representation of the Google exploration and IM Cardboard that they necessarily would not be able to write about. And so they had a lot of students that were interviewed. They interviewed students in their creation of their computational artifact. They had interviews of students that were experiencing the Google exploration and how the middle school kids reacted to it. So that was an interesting computational artifact. And each little group created their own computational artifact, and we kind of looked at that and discussed the different artifacts. This year we're doing Pokemon Go in 1600 Pennsylvania Ave app. So as you can see at the bottom, the Pokemon Go, they've already been writing about that. There's a lot of information basically on the pros and the cons of Pokemon Go, so I thought that would be a good whole group activity, and also the small group activity, so that they could kind of get the idea of pros and cons and harms and benefits and what people are saying about it. And just this past week, since they were working on 1600 Pennsylvania Ave app, I separated them to two groups, so that one group would do the Pokemon Go and the other group is going to do 1600 Pennsylvania Ave app and connect that with augmented reality. Okay, and here's the information on the performance tasks. I know that the rubric, the grading rubric has changed, and we'll look at that in a moment. But basically, explore performance tasks done individually again, and they create a computational artifact, and then they answer they have the write-up with their writing prompts.
So I'm just going to jump in real quick, Barbara. At this point, if anybody has a question, I know Barbara kind of went through a lot in a short amount of time. And
Sorry.
if there's something that that's okay. And if there's something that she referenced that you're like, oh, you know what, I don't know about that, feel free to jump in and ask about it, or ask for more information, and we'd be happy to guide you in the right direction.
Yeah.
If you're all very familiar with it, obviously, we don't want to take too much time on it. She's obviously leading up to the performance task here, but if there's something that you need Barbara to slow down with, please just either raise your hand or type up a question or jump in. Don't be afraid.
I know I went through a little fast, but I'm also cognizant of the time we have left. So right now, let me just. Can you see that? Can you see the video?
Not yet. We're looking at your PowerPoint. It's if you go to sharing, Barbara, and then you share the window.
Okay.
You have to. There you go. Yeah.
Can you see it now or no?
Yes.
Okay. All right. So I'm going to show you right now. This is one of my students' computational artifacts from last year. The reason this was considered probably rated as a 5. The reason I know that it was well liked and it scored high was because he didn't take me out of the video. So when I was one of the readers for the create task, the readers from the Explore task came and told me that they really liked this artifact. But he put a lot of effort into it. Basically, he did animation using Flash animation, and then he videotaped himself. And you'll see he combined the two animations, or the two videos. Here we go. And it's on augmented reality. You can see that, right, Laura?
Yes, I can.
Okay, so this was his non-textual representation of augmented reality. Right now, I just want to show you this before we go back to... Is everybody familiar with the new scoring rubrics? Okay, this is the new scoring rubric, or grading rubric rather, for the Explore task. It looks a little different than the other one. So there's changes to a little bit of the write-up for the how you developed your computational artifact. And then down here for the written response, analyzing the impact of computing. I'm just going to scroll down to the actual rubric. And I've shared this with you if you do not have this from the AP CSP community. But the rubric is somewhat different than the one that was issued in November of 2016 than the one that was modified, I believe, in August. This was completed after they ran a pilot with, I believe, 2 schools testing this rubrics. They decided to do this because in the initial reading in June, there wasn't consistency with how the readers were grading each of the students' submissions, so they wanted to make it so that the readers would be able to give a fair scoring and a more accurate scoring, so that the students would get the best possible scoring of their work. Okay. Please chime in if you have any questions.
Barbara, this is one of the handouts, correct?
Correct. This is one of the handouts. Yes, I gave them the new, and I'm sure they're familiar with this. I'm not sure if anybody has not seen this yet.
And are you all able to see the handouts? Let us know. I don't know if we have to release these or not, or if you're able to just see it in the tab.
Can they see them? Or do you want me to?
I can see on the sidebar the handouts. I am intimately familiar with the document that you have in front. I was really looking for
Excellent.
more info on just the pacing of it and how much time did the kids finish it in the time you gave them? Were they working on it at home? I'm more interested, like this stuff I've seen,
Sure.
like ad nauseum. Yeah.
Okay. My students, they know that they are only allowed to, let me go back to my presentation for a moment. Okay, my students, they were able to finish their work within the eight hours. They know that they can't do it anywhere but at the school. Oh my goodness, it started over. Sorry about that. So, and when I do the mock performance tests, I modify, I tell them they only have a certain number of hours to do it. I don't give them the 8 hours. I give them a smaller amount because they're working as a team on the, when they're practicing. So I usually give them like 3 hours, or I usually give them 4 hours, and then they have to present it, and we discuss what could be modified, so that they have an understanding of what they're supposed to do for the actual explore task, and then they know that they can't do, like this year, they can't do anything on Pokemon Go, and they can't do anything on 1600 Pennsylvania Avenue. But there's so many more innovations they can do it on. I also will be this week be bringing in the media specialist to go over citing in text citation with using APA format. But
it's
yeah,
my understanding they don't have to use any specific format for citing.
Okay, correct? Yes, that's my understanding. I generally tell my students to use APA format because most science, most math, and engineering papers are written in APA format, so we just use APA format. Then they learn both because if they're doing a humanities paper, they learn the MLA. But I tell them APA, just so they're on the same page. I hope I answered your question, though.
Yeah.
Any other questions before we start their create performance task?
So Barbara, when they have 8 hours in class, how do you plan for their time management? Like, do you give them a chunk, like a 2-week chunk where they have to complete it, or is it by individual basis? Where
I usually just have, we just do it as a whole class. Okay, these days, this is what we're doing for the performance task. At the end of, we have 42-minute classes, so I usually say 9 class periods. At the end of the the 9th day, that's it. We're done. It's packaged, and you have to submit it. I have done for the create performance task, because sometimes you're not always going to do a project like in real world all together in a contiguous amount of time. So I might break that up so that they're doing it and they have certain deliverables, but they'll be doing it maybe 3 days out of the week. So that's 3 weeks or 4 weeks that they'll be doing it, but they'll be doing other things. But those, that chunk of time, I'll say like Mondays, Tuesday, Wednesdays, or they'll work on their performance, they'll create performance task. But at the end of those 12 hours, they have to have everything ready and packaged to submit. Because I conferred with some people from College Board to make sure. I mean, they're telling me from start to finish, those 12 hours, everything's done and ready to be packaged and uploaded onto the website.
See, now, from some of the things that I've read, that's a minimum amount, and if you want to give them more time, it's okay. And if they want to work on it, if they need to work on it at home, it's okay. That was the impression I was getting.
Yeah, that my understanding is they have to do it in class time. I think they want it. My understanding is they want it in class time, because not everybody that's working on this has access to the internet at home, and I think you have to have them. You have to kind of see them create their artifacts and their programming. Otherwise, you don't know if they're actually doing it or someone's helping them. They're not supposed to be getting help. At least for the Explore test, explicitly says no one should help you. And with the programming, the create task, they do it collaboratively, but the write-up, they talk about their individual, you know, working on errors and you know, debugging things and solving the problem on their own, rather than they're working at certain points collaboratively, but when they're doing their write-up, they have to talk about their individual successes or challenges in their project. But my understanding, and I've always run it where they're supposed to do it in class.
Yeah, so I was that's exactly what we were planning, but from what I've been seeing is that they're kind of loosening that, and I was just curious, and especially if people are out and they need to make it up, or you know.
Yeah, I mean, I can see that if they're out and they make it up, but they make it up in class, but my understanding, they're not supposed to be doing this outside of class.
So how do you prevent that?
Well, I send letters home. They're going to get a letter that their parents or their guardians have to sign to bring back to specifically say this stuff is supposed to be done in class, because they're not supposed to be doing out of class. And then when you submit it, I'm sure you submitted last year your work, right? There's like that little thing that kind of.
No, this is my first year.
Oh, okay. Well, when you submit it, you have to the teacher, the instructor has to fill out this little form that says, yes, this is their work, and they've done it here. I validate it's their work, you know, and then you have a comment section if you think it's not their work before you do the final submission. Yeah. Oh no, I wasn't sure who I was talking to, so I didn't know whether this was. I heard somebody say that they this was their second year and they did code.org. I didn't know who I was speaking to. I'm sorry.
Oh no worries.
Okay. Yeah, I hope that helps you. I hope that answers your question. I mean, I can get more information and, you know, share it after the webinar if you'd like.
No worries.
Okay.
Hi, this is Kiara. I'm the one who has been teaching it for 2 years.
Okay.
Or this is my second year.
Sure.
My biggest concern with these tasks is pacing, because I have 44-minute periods, and
Right.
I counted out 11 class periods I have to devote to the Explore task, and
Yeah.
17 class periods I have to devote to the Create task.
Yeah.
And I have to start the Create task March 15th, and then we've got spring break, and I'm working all the way up to April 28th. So I have to. My students are finishing the Explore test before winter break.
Correct.
And then I have 8 weeks to teach them programming before they have to start the Create task on March 15th.
Okay.
So I'm really.
Okay. See, what I was doing was I set it up so that they were programming, because they come in and my students just want to program. This is a programming class. And I tell them they have to learn the other concepts of computer science. So the way I set it up is before they start the Explore task, we have 3 days a week they get new concepts. So they're learning about the internet. They were doing history of computers. We're doing abstraction. They're reading assignments, and then they have 2 days where they're doing programming. And so they're kind of scaffolding the programming, or I'm scaffolding the programming with them throughout the course, so that they're not, you know, rushing or trying to learn the programming after they do the Explore test. So they're kind of, the pacing is, they're learning new concepts. That's 3 days a week. And 2 days a week they're doing labs. And they do the labs. And some of the labs even, because our curriculum is the beauty and joy of computing, so some of the labs also incorporate the global impact. So they'll have some of the labs will be directly connected to the Blown to Bits reading assignments. But that's what I do. Then once they complete their Explore task, I flip it so that now they're doing 4 days a week programming, or 3 days a week programming and 2 days of new concepts, because you always have to, you know, challenge them to have them learn new things. Maybe we'll do like you know, a session of 5 or 6 or 7 multiple choice questions, and we'll analyze and discuss those on their new concept days, but they're always doing programming so that when it comes time for their create task, they've got enough in their toolbox to, you know, create a rich program, because they have to have, obviously, a script or an algorithm that shows abstraction along with the actual algorithm that calls 2 other algorithms for the off the grading rubric. So I don't kind of separate the explore versus the create as to, you know, starting after they do the explore, then they start programming. I start them programming a little bit, like almost every week. I don't know if that helps, or I know
that Code.org curriculum has it in this order.
Separated, yeah.
Yeah, and it's and I have another concern with the fact that 2/3 of my course is already taken AP CSA, and then the other 1/3 of the class has no programming experience whatsoever. So it's those 6 students that I'm thinking about having separate sessions with them to get them up to speed on the programming during lunch periods and so on. So I think I'm gonna have to be creative.
So they haven't started the programming, because I have looked briefly at code.org, but I usually use their videos. Their videos are very good, and I like some of their sessions. But since I teach Snap and then we go into Python, I don't use I mean, it's great, but I don't use their programming portion of code.org. I use their videos and some of like their cryptography and their internet videos and lessons. They're great. You know, I incorporate a little bit of everything in my class.
You know, I'm not sure. I'm Eileen, and I'm not sure who else.
I'm sorry?
Go ahead. I'm just curious. I'm also doing code.org, and I'm in my first year, so I can definitely appreciate. I'm not sure who the other person is that was talking that is doing code.org, but I'm in this exact same situation. I have half of my students have done, not half, but I've had several who have done CSA already, and then I'm you know, some that have never done any programming. We've already done a little bit of programming, and then we're going into our explore task right after the holiday. But I'm going to be butt up right up against the April 30th deadline as well.
Yeah, I've counted, and I have to do 17 class periods for the create task, and that's over 6 weeks of time in my school because we dropped classes, and I'm just absolutely freaking out about having to give up that much class time just for a performance task.
I'm with you. We're block scheduling, so I only see them every other day. Wow. And it's the same deal. It's 6 weeks of, yeah.
Yeah. And forget about any kind of test review. I mean, I wouldn't even know how to review with them anyway because I don't see any review materials. Like there's
very
no
little.
book. Yeah, so I'm not even worried. Yeah.
There is a book. I can give Laura the link. It's a Cengate book, and it has a lot of good. It has a good amount of multiple choice questions for review. It's I think it's called Get a 5 on your APCS Principles course. But I'll send her the link. It was still in review over the summer, but I think they're going to be sending out the books in February. So you might still be able to get a sample copy, or review copy. But I'll give her the link. Okay.
Okay.
I don't know. Have you seen that book? Anybody?
I have seen it. I do have a copy. So if you need a copy, I do have one. My supervisor was at a seminar over the summer and got a copy that he scanned.
Oh, okay. There you go. And it has a lot of multiple choice review questions.
It does.
Yeah.
not a tremendous amount, but it's better than nothing, certainly.
Yeah, really. I mean, the course and description booklet has, I think, 40 at the most. It has a little more than that, so, but it's something.
Yeah.
Yeah. Do we have any more questions right now, or should I just continue on? Yes?
Sure.
Okay. Please stop if you have any more questions. Okay, so I'm sure you've seen this. Again, we've got the performance tasks and the end of course. Okay, in the create task, it applies application of ideas. It's the programming. It starts off as a collaborative task, and then this splits off for the write-up as individual. And you can see all this information is on the course and exam description book. And I'm going to go through this quickly because this basically I put in the actual overview or the directions. So the program requirements. The rubrics for this hasn't really, the grading rubrics hasn't changed that much, and here's your submission requirements. You have to have the video. 1 minute in length, can't be more than 30 megabytes, and your written response. And again, I send these to my students as writing prompts, and they also do a mock performance task or create performance task. And here are the questions. So. Right, so then you have to have an algorithm that has two more algorithms or two more abstractions that are called within it, and it's a richly designed algorithm, and then you have your abstraction for 2D to discuss. In here, and you're describing your incremental and iterative development, although it's a collaborative process, you need to write about how you as an individual or how the student as an individual worked with a challenge they had, or debugged a problem that they had. They can't say we did this and we. If they say we too many times, when the readers were looking at that in last June at the in Kansas City for the first reading, those write-ups scored extremely low because it didn't show an individual's idea of what they were creating. They kept talking about we did this and we did that. So some of them got scored zeros when that person just wrote about how he or she came up with a collaborative idea of solving their problem.
Can I ask, do you have your students work in groups? Do they have to work with a partner for the performance task?
They have to work with a partner, but I don't know if you've looked at the course exam, because it basically shows two models, and there's plenty of different models of collaborative. One looks like they're designing one program and they go off and they add on to as individuals portions of the program, and that's what they have to write about. Or another model they have is basically where they have two standalone programs and they just peer review each other's work.
Okay.
So I've had both of those a lot. I think for some of the students, once they do that collaborative thing and they're writing about it, they kind of can't wrap their head around the fact that they're creating this collaboratively, but they only can talk about their the part of the program that they've debugged or that they've created individually. So I tell them that if they're going to create, you know, I've had them where they just peer review each other, and it's two standalone programs. That way, they're going to be able to wrap their head around that you're going to write about your individual work. You know, you could have somebody else look at it and say, hey, maybe you'll try this. But they're going to be working, you know, talking about their individual work.
Mm-hmm.
If that helps. So to get back to the slides, you can see you mark an oval for the algorithm and a rectangle for the abstraction. What I also do, a lot of my students last year, they did their program in Snap, which is block-based. They basically, when they were doing discussing the algorithm and their abstraction, I also had them post take a screenshot of their work, of their script, and put it next to their write-up so that the reader could actually see their algorithm, and then it was calling different algorithms, and then what they were discussing is their abstraction. Because it wasn't always clear with the oval and the rectangle in the actual programming code what they were discussing, so I personally had my students do that.
Barbara, just a heads up, there's 5 minutes left. So maybe just try and gauge,
okay.
you know, what you
goodness.
have left and,
right.
you know, time for questions.
Okay, very quickly. All right. So you can see, I'm just going to skip it through, 12 hours. Here's the scaffolding. So we do flow charting. I do computational, the algorithms. We discuss the abstraction in the internet and different layers of abstraction. And then your programming, the variables, conditionals, text. We do mock create performance tasks as well. And here's some of the ideas. Again, you can use the board games to as a stepping off point from the you know, earlier in the year. You'll just revisit it again. Board games. I always have my students analyze their algorithms. You know, write out the pseudocode. What do you think you want to do? I put little whiteboards at all of their workstations so that they can sit there and write it out. We discuss their algorithms during the programming. When I go through rubrics and I'm grading, one of the things I check all the time is they have to tell me what their algorithm is doing, so that, you know, we can follow through and I can make sure they understand it. And then they also do more flow charting. We discuss abstraction as a functional abstraction and also data abstraction. This is from the Explore task. So for the create performance task, you have to create a video of your programming functioning. Then you have to, you know, get write-ups, and then you have to submit your code. And this is, you can actually go through, and this is the algorithmic board game, but you can see how it connects with several big ideas. And then you go through and you look at the learning objectives and the essential knowledge from the exam description and course booklet. And building out the Explore PT is 16%. The Create PT is 24%, and the other 60% comes from the 74 questions for the exam. Any questions? No? We're done.
Don't be shy.
Huh?
I said, don't be shy. Feel free to jump in. Now's your
Any
chance.
questions?
Yeah, it
I
sounds
think
like,
somebody's raising their hand.
Okay, Renard. Yep.
Renard.
Okay, let me unmute. Okay, Renard, you can ask.
Hi, we're not there yet, as I mentioned before. I was wondering how accessible it will be in the future via email or so. I just want to have some question for your regular curriculum for computer science as a preparation for going to the next steps where you already are.
You're asking for Barbara's email address or contact information?
Yeah, email is better way for her. What is?
Yeah, I forgot to put. Yeah, I will send you. I can send you my email. That's
Okay.
fine. I just didn't put it on there. I apologize.
Yeah, Barbara.
No problem. I had it from the previous presentation that I followed you from the Out of Code organization.
Okay.
I was wondering, that's the best way to reach you?
Yes.
Okay. Thank you very much. I enjoyed this.
Thank you. And Barbara, you can put your email address in the chat if you'd like as well.
Sure. I'll do that now.
Okay. And then thank you so much for attending, everybody. I know your time is valuable at night, so we don't want to take you past 8:30. I will be sending a follow-up email just with a link to a survey, and if you could just answer a few questions for us just to help us improve for future webinars. And then once you submit your survey, I will send you a professional development certificate for 1 hour. So again, thank you, and have a great night. Barbara put her email address in the chat window, so I'll leave that up. I'm just going to stop recording now.